We're going to take a small aside before we go to the hard questions, bless you, and talk about, this is an aside. So it's like the main topic, but it's to the left of the main topic or to the right of the main topic. It's, you know, like it's a box in the textbook that says something different that's related. That's an aside. And we're going to call this the range equation. Just more stupid math. So here we go. Let's imagine the same situation we've been talking about, a situation in which we are going to launch something on level ground. It will be launched at some starting angle. And as we know, it's going to land over there someplace. All good? All right. We are familiar with this problem, familiar enough for us to set up a generic set of information. I say generic because I'm not going to put any numbers down. I know that in the vertical direction, we're going to have delta y. We're going to have Vy initial, Vy final, acceleration, and time. On the horizontal side, we'll have delta x, also known as the range, Vx, and t. Now, we know that these are the vector quantities. They have to be given direction. And we also know that if it's launched at an angle, that the trig suggests that this will be true for the initial y velocity, and this will be true for the initial x velocity. And the x velocity won't change. All good? We're also aware that for most of this, gravity is going to be the acceleration. Now, for this particular problem, because it's a type 2 problem, I can put a big 0 here. So what we're about to do is based on this particular problem and the placing of a 0. This will only work if delta y is 0. I'm being super clear about it because if you try and use the results of what we do here any other time, it won't work. And some of you will try. I'll see it on your quizzes or your tests. And in my head, I'll be chuckling because I'll know you didn't listen to this very important public service announcement that this only works when delta y is 0. So that being said, what I'd like to do is solve the problem, but not use any numbers. I want to come up with an equation that eliminates t. If you've paid attention the last 2 days, you know that we are solving for t on this side and plugging it in on this side every single time. That is the process of eliminating t. So we're going to create a new function that eliminates t. I do need to deal with direction because that's important. Do you want up to be positive or up to be negative? Do you want to the right to be positive or to the right to be negative? Okay, so that makes this positive, that makes this positive, and it makes gravity negative. Okay? Everybody good so far? We're going to just abbreviate gravity as G. Is that okay? Okay, here we go. On the right, I will have delta x equals V naught cosine theta times t. On the right, I will have 0 equals 1/2 times negative g t squared plus V naught sine theta times t. That's a lot of letters, isn't it? So I know, again, some of you, this is going to look like alphabet soup. It's okay. Just follow along till I get to the end, all right? Which one of these is easier to solve for t? The left one or the right one? So let's solve the right one for t. T equals, and I'll have delta x over v naught cosine theta. All right. The left side. Do you notice there's a t in both of those? Let's factor out a t. We'll say that one of the t's we know is equal to 0. We'll factor that out, and we'll all admit that we don't care about that one because that's the one when the problem is first started. And now we're interested in dealing with the other t, which is the t that's left over, the one that will be when the object lands. So I factored out a t and set it equal to 0. All good? Everybody got that part? Got a couple of nods, so I'm going to go with it. So now I have to do the substitution, right? We're going to take this guy and put him in there. So 0 equals, I'm going to write this as negative g over 2, because that's really what it is. If I multiply 1/2 times g, I just get half of g. And then inside the parenthesis, I will have delta x over v naught cosine theta plus v naught sine theta. Everybody good here too? Okay. Now, I want to solve this for where the object lands. And where the object lands is this thing buried right there. So I'm going to take all of this and just move it to the other side of the equation and make it positive. Now I kind of combined two steps at once there. Are we okay with that? I distributed the g and the 2 inside the parenthesis. Okay, so I'm going to multiply both sides by this. Okay? I know it's not 0 or it wouldn't be in the denominator. So I will multiply by 2 v naught cosine theta times 2 v naught cosine theta. It cancels it out there and leaves me with g delta x equals, oh, that looks yucky. I'm going to write that as v naught squared, because there are 2 of them, times 2 sine theta cosine theta. I know you probably don't know why I grouped the 2 with those, but I have a reason. I'm going to divide both sides by g. That will get rid of the g's on this side. Okay. Now, do you remember our problem just from yesterday? The launch velocity was 2, the acceleration was 10, and the angle was 30, right? So delta x equals 2 squared times 2 times sine 30 cosine 30 all over 10. This should give us the same place, right? It should be exactly the same. So I'm going to try it. I got my calculator all fired up. It's actually one of your calculators. Somebody left it. It's mine now, but yes.
Isn't the gravity, wouldn't it be negative?
No, we made it negative at the beginning, right? Remember we made it negative and we put it in here as a negative. So we already did that part.
Oh.
And the reason I did that, I could do what you're suggesting, but that makes you start thinking that gravity is always negative 10. And I want to also make sure we know that gravity is not negative 10, it's 10 downwards. Does that make sense? Okay. All right, so again, 2 squared times 2 times sine 30 times cosine 30 Glad I got one of these fancy calculators now. Divided by 10. And just like yesterday, 0.346 meters. Right? That what you guys got? But you know what we can do with this that we couldn't do yesterday? Like, this one works out great. But we can do other things now. Because yesterday, if I had asked you, okay, instead of me giving you how fast I hit it, what if I tell you I want to hit a target that's further away? A target that's 0.5 meters away? I don't know that we could figure out what V would give us 0.5 meters, right? Because it shows up in two places. But I think now we could. Because we just have one equation. This one. So if I said, okay, I want to hit 5 meters, what V would do so at 30 degrees? You could probably figure it out, right? You just put all those numbers in and solve for V. But there's something else here, and it's even, I think, better than that. So, and I have to do something, but I hate this. Like, if I was to ask us to solve for theta, do you realize there's no way to solve for theta here? Because how do you solve for theta? I can't do inverse sine because I have sine and cosine. Do you see how that's a problem? Who here has ever heard of a trig identity? Okay, so 2 of you. Can you give me a trig identity that you know? Or have you just heard of them but don't really know what they are? Go ahead. It can be any trig identity you know. It's okay. Go ahead.
Sine squared x plus cosine squared x.
Yep, that's a trig identity. So I assume you guys have seen a couple. So sine squared theta plus cosine squared theta equals 1. That's a trig identity. What that really means is that if I have sine squared in my problem, I could replace it with 1 minus cosine squared. A trig identity is replacing one function with another function. I think you all know this one. Sine theta over cosine theta. What does that equal? That's right, it equals tangent. It's a trig identity. There are lots of trig identities because ultimately trig identities are just the same 3 numbers. Opposite, adjacent, and hypotenuse, all mixed up. So there's lots of trig identities. How many of you have seen this one? Oops, I wrote it wrong. Hold on. How many of you have seen that one? Okay. I want to use this one. It doesn't look like it will help us, but just watch. Just I don't care if you ever can do this yourself. I just want you guys to know things. I'm going to replace all of the B's with A. So it's sine A plus A. Now if I do that, do you notice on the right side that it's 2 sine A cosine A? So you just add those 2 things together. And on the left side, it's sine of 2A. Do you guys see all those things I just did? Now you might not know why I wanted to do that, but I'm going to show you. Now do you see why I wanted to do it? I have a trig identity that could make this simpler. Do you see it? It says 2 sine A cosine A equals sine of 2A. So I'm going to substitute. And when I substitute, I will get delta x equals V naught squared sine 2 theta all over G. I don't really care if you can reproduce this. What I care about is that it is very likely that while doing your homework one time this weekend, you will look at the internet and the internet will tell you this. I want you to know where it came from. So you saw where it came from. I also want you to know that some of you are going to use it wrong. So I'm telling you right now, this only works when delta y is 0. If you use it any other time, it's wrong. Any other time. It can't tell you the maximum height. It can't tell you how long it takes something to get there. It can't tell you if it gets over the trees. All it can do is tell you where the object lands or how fast it should be shot. Or, and there's one more thing it can do, it's the only time you could ever be asked what angle to use. This can be solved for the angle. I want to give you an example of this being used to solve for the angle because it's one of those problems that you could be asked to do. It's in your homework, so I want to see if you can kind of work this one out. And so this is no longer an aside. This is a special case. So there'll be football games starting tonight. At some point or another, there's likely to be a situation in which somebody's going to try and throw the ball to somebody else. Can we kind of agree that if you're throwing a ball to somebody else, that's kind of a delta y equals 0 problem? Okay. Assuming both guys are about the same height, that should work. So let's say the quarterback has the capacity to throw the ball at 20 meters per second and wants to throw it downfield to a guy who's 35 meters away. What angle should they use? You can only answer an angle question if you use the range equation. It's very difficult to use anything else. Now, there are times you might be able to find the angle under special circumstances. But for the most part, the range equation is usually a situation in which you can answer a question that asks about the range. But it only works when delta y is 0. So the range equation, delta x equals v naught squared sine 2 theta over g. You notice that we have everything that we need to solve for theta. We just have to plug those numbers in. So delta x is going to be 35. V naught is going to be 20, but we have to square it. Sine of 2 theta, all divided by 10. Yep. We will always use a positive 10 because we put the negative in when we solve for that equation. Now, I'm just going to do a little bit of math here with you, but I want you to have your calculators out for this next part. This will be 35 equals 400 times the sine of 2 theta divided by 10. 400 divided by 10 is 40, sine of 2 theta. And that means sine of 2 theta is 7/8. Again, I'm doing the algebra for your benefit because I want you guys to be able to see the steps, but truthfully, I don't like doing algebra. Can somebody find theta for me? You have those fancy calculators. Be careful, because it's sine of 2 theta, so you have to take the inverse sine first and then divide by 2, right? So, for example, I'm going to put 7/8 in the calculator, and I get 0.875. So I'm going to hit inverse sine, and I find that 2 theta equals 61 degrees. Is that what you guys get? Are we all good? We're all in the same place? Now, that's not the answer. The quarterback should actually throw the ball at 61 divided by 2, which is 30.5 degrees. Okay, so we're all good. We're all at the same point I'm at, right? Here's the weird thing. Your calculator always gives you the first quadrant answer. You guys know a little bit, so I think we can do this. Right? It gives you an answer between 0 and 90 degrees. Right? That's what your calculator does. Now that makes sense. If you're the quarterback and you're throwing the ball, would it make any sense to throw the ball this way if you want to hit a guy over here? Would that make any sense at all? But hear me out. Sine is positive in both of these quadrants. So you got your calculators out, right? Do me a favor and find the sine of 119 degrees. You notice you get 0.875, right? Do you notice that? Because the truth is, there are lots of answers to this function, right? Every time we go around again, we get another answer. So although 2 theta equals 61, 2 theta also equals 119 degrees. Now, normally we wouldn't care because, like I said, does it make any sense for the quarterback to throw the ball behind him to go forwards? It wouldn't, except that we're going to divide by 2. What's 119 divided by 2? Now, you don't always have to do it the way we just did it. You will notice these two add up to be 90, right? Whenever you use the range equation to find an angle, there are going to be 2 angles. The first angle you get is the small angle. Its complement will be the big angle. How many of you have ever used a hose to, sploosh somebody in the face? Right? All of us, I hope, have had this experience. Have you ever done the sploosh them in the face, but also like the death from above? So you shoot the hose up so it goes way up and comes back down? Has anybody done that? Like they hid behind the car, so you put the hose in the air and it goes. The water's all coming out at the same speed, but you can get the right in the face, or you can get the time delay where you shoot up in the air and it comes back down and hits them on top of the head. 2 angles every time for this problem. So there's always 2 angles. Now, again, not a sports fan, but if the quarterback wants to get the ball there fast, they use the low angle. It's in the air less time. And that's why they use the low angle. It beats the defenders there. But if the quarterback wants to give the player time to get to the spot, they use the high angle. It gives them more time. And that's also what kickoffs and punting's about. Right? You punt using the high angle, not the low angle. Because you want time for your offenders to get down there and cream the little guy who's going to get that ball. Same idea here. There's always 2 angles for these problems. They're always complementary, though. They'll always add up to be 90. All right. That's a lot. So Right now, you have everything you need to do everything that's on the primer page. So if you're doing the extra practice, 100% of it is done. This is the last stuff you need to do any problem that doesn't conform to a type 1 or a type 2. There are no shortcuts here. And I'm not going to teach you anything new. I want to show you that this problem is the same as the others, except that you don't get the shortcuts. In the other ones, you had shortcuts. There were things you could do that were easy to get to the answer. This one, you have fewer shortcuts. So consider an object that's being launched at an angle, but is also going to be above the ground. So let's say shoot it at 30 degrees, 2 meters per second. So we're doing the same problem as yesterday, off of a table 0.75 meters tall. Remember yesterday's, we just let it roll off the table, and then we were on the floor and we just flicked it off the floor. Now we are shooting it off the table. When we do this problem, all the same things we've been doing this whole time still show up. So there's really no difference to the setup of this problem. I'm going to have vertical and horizontal. I will have delta y, vy initial, vy final, a, and t. I'll have delta x, vx, and t. Do you want upwards to be positive? Do you want to the right to be positive? All right, so let's work this out. Delta y will be downwards 0.75 meters. Right, it lands below where we started. Vy initial will be 2 sine 30 degrees and will be positive. I don't know Vy final, but I know the acceleration is going to be 10 meters per second squared and will be negative. I'm probably trying to figure out where it lands, so I don't know delta x. But I do know that my velocity is going to be positive 2 cosine 30 degrees. Here is why these are hard. In this problem, if I want to find the time, I'm still going to be using delta y equals 1/2 at squared plus vy initial times t. There's no zeros, right? You see that I don't have a zero to put in anywhere. So negative 0.75 equals 1/2 times negative 10 t squared plus 1t. I don't have a simple way of getting t. I get 0 equals negative 5 t squared plus t plus 0.75. Do you see the problem now? Why this is harder? Right, you understand. You will have to do a quadratic or something like that. Now, I'm going to level with you. I want you to be able to do this. Okay, I want you to be able to do this. Your test might have you do this once. Just once. But I want you to be able to do it. You know how to, right? Quadratic function and all that. I don't have to spell that out. You're going to get 2 times. Most of the time, one will be negative and one will be positive. Which one is your answer? Positive one. There's still the same other questions. How high does it go? That doesn't involve this. There's what angle it hits the ground. That's not hard. It's the same. You don't have to do this. You only have to do this if you're being asked where it lands. But you'll have to do this if you're being asked where it lands. Now, there is the possibility you could get 2 positive times on a problem like this. And I want to show you the ones where that would occur. The only way that would occur is if you're trying to lob something up on top of like a building. If you lob something up on top of a building, you shoot it upwards, there could be 2 times that the object is at the right height. Do you see that? There'll be the time on the way up and the time on the way down. So the building could be placed any location here and it still might make it to the top of the building. So if you get 2 positive times, you may have to test them both to see which one is the right one. But that's unlikely. Most of the problems will be it lands below where it started. You have to find out the one time that's positive. All right.